Okay, welcome back to part 3 of our 5-part developer series, right? So far, going through the series, in the first module, we created a simple web server with a hello world type get call. In the second module, we went over how to create gets and posts. In this module, we are going to be good developers and we are going to create a unit test. Now, is a unit test something that is specific to Spring Boot? No, not at all. All code has unit tests, but I did have a few folks expressed interest in unit tests and how that may work in Java. So we're going to use JUnit for that, and without any further ado, we're just going to jump right into it. So, step 1, we're going to create a demo3 directory to store all our code in. Tutorial video. Nope, that wasn't right. This is demo 3, not demo 2. Alright, demo 3. And then we're going to come over here to idea. We are going to go to our project we just created, demo 3 tutorial video, and we're going to open it up. Alright. From this point, we are going to go new, module, demo 3, com dot coffee code creatine at nope dot education demo 3 JDK 14 Java 11 packaging jar type Maven. We're going to hit next. We're going to get Spring Boot 2.7 and we're going to hit create. Somebody somewhere along the line is going to tell me, why do we keep doing this? This is the third time we've created the same project. Why don't we use the previous one? Muscle memory and education. As you get further and further into coding, you are going to have a lot of different technologies and things floating around in your head, and a lot of people fall into the scenario of either using the same project or copying and pasting code from somewhere else, and before you know it, they don't remember how to make projects from scratch, or they don't remember what imports do what. So for today, we're just going to do everything as manual as we can, with the exception of the IDE actually giving us a fair bit of help on importing the packages that we have manually added. So we have our demo 3 set up. We are going to be using Spring Boot Web. So we need to go to our Palm and get that added in again. So dependency group ID is org.springframework.boot, and then we need Spring Framework Starter Web. Cool stuff. Alright, again, we don't need our version in this scenario because we have it up here. Refresh Maven dependencies, and then we go over to our demo 3 and we are going to start creating our controller. So we have our controller. We will go ahead and hit a Java class, and I guess we'll call this demo 3 controller. Okay, cool stuff. So how do we want to go about this? What do we want to build? What we could do is create let's say an endpoint. We'll call it isPrime. That endpoint we will pass in a JSON body, right? So this will be a post call as opposed to a get. Could we make it a get call and use a path variable? Yes, but path variables are a little less common, especially in backend work. You a lot of times use posts and pass around JSON bodies, so we're going to stick with that. So we will create this post method. We will pass in a number. We will check to see if it is prime, and then we will create a unit test to check that is prime method. So let's go ahead and get started. So first things first, we are going to need to annotate this guy with REST controller, and then we need to come down here and create a post mapping, right? So we're just going to call this is prime. We're not getting super creative with the naming today. We are going to want a object to pass back and forth. So perhaps what we could do is something to the effect of custom JSON response, right? We'll have is prime, and we will pass in a request body, and we will call this custom JSON request, right? And then we'll actually do, our work in here. We will have to define these custom JSON responses and custom JSON requests, though. So for our custom JSON response, nope, that's not how this works. It would be, let's go public, static, custom JSON response. How do you write classes? There we go. And what we will have in, why are you upset? Because we need class. There we go. All right, so inside of this custom JSON response, we should probably have like a potential prime number, and I think that's realistically all we need. So we'll go int, talking and typing at the same time, sorry. All right, so we'll have a potential prime, and then we'll go ahead and create our constructors. So we'll have public custom JSON response. We will go int potential prime, and then we'll go this dot potential prime equals potential prime. Okay, and we'll go ahead and I guess create our empty constructor. Blink. And now we need to generate our getters and setters, so let's go ahead and do that. Generate getter setter. All right, there we go. Now we need our custom JSON. Oh no. So this class up here, we called it response, but this has our potential prime. This is what we are passing in. This should be the request. So let's correct that. Okay, and down here, oh, now we gotta update our constructors, that's fine. Request. All right. Sorry about that. And then down here, we will actually work on our response. So JSON response. And this is going to have, let's say, a Boolean for is prime. And then let's say we have a string for message. Now, what are we going to do with that message? The purpose of this video is to go over unit tests, not cryptography, but checking to see if a number is prime is actually fairly expensive and hard. So what I'm thinking we do is inside of our is prime, we will have a max number that we can compute. For example, for example, we could say the max, man, drinking problem. All right, for example, our max value could be something like 10 or 100, right? That way somebody doesn't come along and try to send in a 20-digit number to check if it's prime. So, as such, same sort of deal for our response. We need our constructors. So let's go Boolean is prime and then string message. We'll go this dot is prime equals is prime, and this dot message equals message. Right, and then we'll have an empty constructor like so, and then we will generate our getters and setters. There we go. All right. Responses and requests set. So now all we have to do is worry about math. Okay, so let's say we have a Boolean is prime, and then we will have our custom JSON response, be new custom JSON response, And then what we're going to do is we're going to do a try catch. Boink. Alright, and inside of our try, because what I'm thinking we do is this prime method that we're going to be making, in the event that we have something over our max value, we just throw an exception. So, if we throw that exception, we need to be able to catch it here. So we'll go is prime equals, let's say we'll have a util and we'll call it prime numbers dot is prime. We'll go custom Json response. We'll call this like something like gets, actually no, this is not the response, this is the request. And we need to go get potential prime. So the plan here is we will get our potential prime out of the request. We'll create a util class called prime numbers, which will have an is prime method, and then we'll just kind of invoke that. And then what we're going to do here is in our response, we will set is prime, set prime to is prime. And so is prime, set prime into our response. So there, that should handle all of that. In the event we do throw the exception, we can do something like custom Json response set message, and then this will be unable to compute prime number, right? And then down here, we'll just return the response. There we go. Okay, so I'm going to try and compute a prime. In the event we can't, we tell our user about it, and then we return the message. So let's go ahead and create a util package, util, and then in here we will create a prime numbers class, prime numbers, boop. And now we have to create a prime numbers method. Alright, so in here we can go public static boolean is prime. We will pass in just a general number, right? We've already decided this will throw an exception, and so this will be our method. And so we did say we wanted to have a max value, so we'll say int max value equals 10, and then we can do something to the effect of if n is greater than or equal to the max value, we will go ahead and throw our new exception. So throw new exception, and we will say value too large for prime number method. Okay, so that takes care of that. And then, in the event we are willing to compute, we need to come down here, and we need to have a corner case for prime numbers. So I'm not really going to get into the whole like how to compute a prime number thing. We're basically just going to like brute force this and see if we can divide. But there are other quadratic sieves and all sorts of fancy math you can do. We're not worrying about that today. But in the event we do go through the method of just like simple division to see if the number is divisible by 1 in itself, we need to have a corner case for 1, right? So if n is less than or equal to 1, we just need to return false. So let's go ahead and get that out of the way. And then we're going to come down here, and then we're actually just going to do the math. So we're going to go for int I equals 2, I is less than n, plus plus, and then we are going to want to come down here into our if statement, and I think it is if n mod I, not 1, mod I equals 0, then we're going to want to return false. And then if we make it all the way through our loop, then we want to return true. If if we could, oh my god, if we could spell. Okay. I think that's going to work. But this is the reason that we write tests to test our code. And if this logic makes no sense to you guys, don't worry about it. I'm not worried about understanding how to compute a prime number. Okay, so back inside of our demo 3 controller, we now have this prime numbers class, which we want to go ahead and import that. So if you're using IntelliJ option enter, brings up this little potential solution window, and then we can just go import class. So, all good things here. And now, if we want to, we can go ahead and run this. We haven't tested our code yet, but we're gonna run it just for amusement. Server starts up, we have is prime, and we are passing in, what did we call it? Potential prime. So let's go ahead and go localhost 8080 / is prime, right? And then from here we need a body. This is supposed to be a post raw JSON, and we are going to go potential prime, and we're just going to pass in like 3. 3 is a prime number, right? All right, message null, prime, true. Beautiful. But let's say that max value was something significantly higher, or we wanted an automated way to test this rather than going through Postman. We can write unit tests. So if we go down to our utils and hit prime numbers, there is a shortcut in IntelliJ, I believe it is Command-Shift-T, which will allow, nope, that's not right. Command-Option-T? Command-Option-T, right? You can create tests. So all we're going to do is go Command-Option-T, and we're going to create new test for this prime numbers method. We're going to use JUnit5, class name, prime numbers test, destination package, pretty much everything here autofills. But this will be demo 3 utils inside of our test directory, and we want to generate test methods for is prime. So we're going to hit OK. And now we have a nice little test that has spun up. And so the way we can test code, especially with unit tests, is massive. For lack of a better term, there are quite a few frameworks and libraries that allow you to make different annotations for different inputs. We're not necessarily going to use any of those today. We're just going to go bare bones. And so the importance of having multiple inputs is, for example, we have is prime, and you might want to test 0, you might want to test 1, you might want to test 2, right? You might want to test all the way up to 1,000,000. You're not going to have 1,000,000 is primes. You are going to want to have some type of generated input that gets fed into this method. That will be a topic for another video. Today we are just going to create effectively a list of the numbers that we want to test and then pass that into the method itself. So that all out of the way, let's go ahead and get started. So what I'm going to do is I'm going to go ahead and create a hash map. And in this hash map, I'm going to have an integer and a boolean. And we're going to call this solutions. And what we're going to do, let's go ahead and spin this up real quick. There we go. All right, and so inside of solutions, what we're going to do is we are going to effectively make a answer document for a unit test. So for example, 1 is not a prime number, right? Solutions, we'll put 2 in there. 2 is a prime number. Having a hard time typing today. Right, and we'll go ahead and go like all the way up to 10 just for fun. So solutions dot put, we'll have 3. Right, so bear with me while I knock this out real quick. Let's just do this. I know I said copying and pasting is bad. I don't think anybody's going to get too upset with me for copying and pasting a put into a hash map. If you are, throw me a comment and we can discuss it in the comments. Okay. Who knows their prime numbers? Okay, 3 is prime, 4 is not prime, 5 is prime, 6 is not prime, 7 is prime, 8 is not prime, 9 is not prime, 10 is not prime. Okay, solutions. So now what we're going to do is we're just going to iterate through that map, grab the key, pass it into the prime, make an assertion saying this is correct, this is not correct, that is correct, not correct. We will AND those together as we go, and then in the event everything still ANDs up to true, we know we pass. So, for loop. For int I equals 0, I is less than 10, I plus plus, right? And so then we're going to go try, we are going to create a boolean is prime, we are going to call prime numbers dot is prime, we are going to pass an I, and then we are going to say assert equals solutions dot get I, and then we are going to go is prime. There we go. So what we're going to do is we are going to, is prime I. No, just is prime, sorry. So what we're doing is we're computing if the value is prime, and then we're going to assert that whatever that method gives back, right, true or false, matches what we have in our solution set. And then so here, as our method does throw an exception, we need to be able to catch that. And so what we're going to do here is go system.out.println. We'll just say exception thrown. And then from here, just to break the test, we're going to assert true equals false. Obviously, this will never be true, so this will break the test in the event we do throw this exception. Right? And so what we're going to do is all of the asserts, as long as they're true, this test will pass. If any of them are false, it'll break. So we can run is prime. And with a little luck, we messed something up. So perfect. This is exactly why we write unit tests, is so that whenever things do break, we can go through and figure out why. So the question here is, what did we foul up? This right here. We wanted to start at 1, not 0, because 0 is not in our solution set. Let's try that again. Yay, all right, everything is working. Now, something that we should go ahead and call out is our prime number method, is capable of throwing an exception. So we should probably test the scenario where we know we want an exception to be thrown. So we're going to annotate a method is test. And I guess I didn't call this out, but this test comes from JUnit, right, this test annotation. And all that is doing is basically saying, hey, this method here, run it as a test, right? So void, or public void, void public, don't we care? Let's go void is prime to large. And then we will go ahead and test the case where we pass in a prime number that is too large. Now, in this scenario, we know this is going to throw an exception, so we actually want to assert that this code is going to do exactly that. So what we can do is go assert throws, right? We'll come in here and we will say exception dot class. We're just throwing a standard normal exception, and then we are going to, what is the word for this? I guess write a lambda that is going to be executed inside of this method to get our responses back. So if you're familiar with JavaScript at all, or anything that uses this type of executable, open parentheses, arrow, curly braces. And then inside of this here method, we are going to execute our function. So we could do something to the effect of boolean is prime equals prime numbers dot is prime, and then something like 11 would break our test, right? But we're not actually doing anything with this is prime. We just need the exception to be thrown. So we are calling this method. We are effectively using a method call as a parameter to this assert. And so whenever we run this, the exception will be thrown, the assert throws will pick that up, and then we'll pass. If we passed in something like 9 that would not throw the assertion, this test will fail. There we go. All right. So assertion failed error, expected exception to be thrown, but nothing was thrown. So that is how you can test for exceptions in JUnit 5. And that is realistically all the more there is to it. This is a real simple unit test for our method. We've got a simple test case where we want input in, input out, and then we have a test case where we have input in and exception out. So I guess the only thing that we could demonstrate is whenever we run the application, what happens whenever we do actually pass something like 11 into our service. And what we're going to see is because we are catching the exception inside of our REST controller, rather than seeing an exception thrown to service and the service vomiting, we're just going to have an unable to compute prime, and then the response that comes back is actually going to be false. Booleans are falsy by default. So rather than having like boolean null and then unable to compute prime number, we will have boolean false, unable to compute prime number. So if we come over here and we say 11, right, unable to compute prime false, exactly as we'd expect. And so with that, this concludes demo 3.